Good evening, everyone. I am M. Purnima Devi from SNS College of Technology, Department of Artificial Intelligence and Machine Learning. Today, I am going to discuss about full stack AI and intelligent agents. So, what is an agent? An agent is anything that perceiving its environment through sensors and acting upon that environment through actuators. Example: human is an agent. A robot is also an agent with cameras and motors. A thermostat detecting room temperature. Intelligent agents. So here the basic structure of intelligent agents. So here environment, percepts, actions, sensors, agent and actuators play an important role in intelligent agents. So the intelligent agent collect the information from the environment and change the program according to the environment. So it collect the informations in the form of sensors and actuators takes the involvement of programs and they modified and they given return to the and take actions and give return to the environment. So diagram of an agent. So here is an diagrammatic representation of agent. So here agent. So we take that agent or one group and environment or second group. In agent, the sensors. The sensors were given to some of the particular in point, and the particular point and the particular action will be taken and given to the actuators. So actuators may involved in taking the environment easily and access the information and given the information to the environment. So actions. So sensor percepts actions actuators play an important role in agent. So the percepts where the information given into the sensors and the sensors given into the some of the point and the points were accessed and given into the actuators and the actuators actions will be taken to the environment. Simple terms: percept. Agents perceptual insects at any given instant. Percept sequence. Complete history of everything that the agent has ever perceived. Agent function and program. Agent's behavior is mathematically described by agent function, a function mapping any given percept sequence to an action. Practically, it is described by an agent program. The real implementation. Vacuum cleaner world. Perception. So clean or dirty. Where it is in actions. Move left, move right, suck or do nothing. So here we considered this is an vacuum cleaner. A vacuum cleaner is placed into a two kinds of room where we taken A as an one room and B as an second room. The vacuum cleaner is mainly it has four actions where either it can move left or it can move right or it can suck the dust or it can do nothing. In this picture we can represent that vacuum cleaner is placed into a room and it is an rest position. It does not take any position. Vacuum cleaner world. Percept sequence. A clean, so right. A dirty apna suck, so B clean apna left. B dirty apna suck. A clean A clean right. A clean A dirty apna suck. So here the motion will be continuously executed. From last all the clean rooms are neatly cleaned. A clean, a clean right. A clean, a dirty suck. So partial tabulation of a simple agent function for the vacuum cleaner world shown in figure before slide. So program implements the agent functions tabulated in figure 2.3. Function reflects vacuum agent, location, status, return and action. If status equal to dirty, then return stuck. Else if location equal to A, then return right. Else if location equal to B, then return left. Concept of rationality. Rational agent, one that does the right thing. Every entry in the table of the agent function is correct. Rational. What is correct? The actions that cause the agent to be more successful. So we need ways to measure success. Performance measure. Performance measure an object function that determines how the agent does successfully. Example 90% or 30%. An agent based on its perception. Action sequence. If desirable, it is said to the performing well. So universal performance measure for all agents. Performance measure. A gentle load. Design performance measure according to what one actually wants in the environment rather than how one thinks the agent should behave. Example, in vacuum cleaner world, we want the floor clean no matter how the agent behaves. We don't restrict how the agent behaves. Rationality. What is rational at any given time depends on four things. The performance measure defining the criterion of success, the agent's prior knowledge of the environment, and the actions that the agent can perform, the agent's percept sequence to data, rational agent for each possible percept sequence, and rational agent should select an action accepted to maximize its performance measure given the evidence provided by the percept sequence and whatever built-in knowledge the agent has. Example an exam. Maximize marks based on the question on the paper and your knowledge. Rational agent performance measure. What's 1 point for each clean square at each times step over 10,000 times to its prior knowledge about the environment. Example of a rational agent actions that can perform left, right, suck or no. What's the sequence? Where is the agent? Where the location contains data. Under the circumstance, the agent is rational. Omniscience. An omniscience agent knows the actual outcome of the actions in advance. So, no other possible outcomes. However, if impossible in real world. An example: crossing a street but died of a fallen cargo door from 23,000 feet. Irrational. Omniscience. Based on the circumstance, it is rational. As rational maximizes expected performance, the perception maximizes actual performance. Hence, rational agents are not optimized. Learning. Such a rational agent depend on only current percept. The past percept sequence should also be used. This is called learning. After experiencing an episode, the agent should adjust its behaviors to perform better for the same job next time. Autonomy. If an agent just relies on the peer knowledge of the designer rather than its own perception, then the agent sucks autonomy. Rational agent should be autonomous. It should learn what it can do, compensate for rational or incorrect prior knowledge. Software agents. Sometimes the environment may not be the real world. So flight simulator, video games, they are all artificial but complex environments. The environments working these environments are called soft bots. Task environments are the problems where the rational engines are the solutions. Specifying the task environment fields, describing as fully as possible performance environment actuators and sensors. So use automated taxi driver as an example. Taxi environments performance measure. How can we judge the automated driver? Which factors are considered? Getting to the correct destination, minimizing fuel consumption, minimizing the trip time or cost, by minimizing violations of traffic laws, maximizing the safety and comfort, etc. Thank you.